I hope you're ready to continue on our path to learning the different transformations. I'm going to remind you that what we are learning right now is definitely hidden in apps on your phone, video games, movies, animated movies, things like that. So we've already talked about the first transformation, which was a translation. A translation's nickname would be a slide. So if you're playing a video game and something just simply moves across the screen, that would be a translation. Today we're going to talk about reflections, and of course you're going to immediately think about a mirror. And if you look at the picture on the screen, you can see this mountain reflected in the water below. So we're going to talk about reflections, and a reflection nickname would be a flip. So the idea that we turn something upside down or left to right. So we're still working on the essential question of how can you best show or describe the change in the position of a figure. We're simply moving figures around the coordinate plane. And again, these steps would be hidden inside a computer program that is moving things around a screen. So as I look here today, we're going to talk about reflections. And basically, we're just going to look about reflecting over the x-axis and reflecting over the y-axis. So remember, y to the sky, right? You can reflect over any line. It could be a diagonal line. It can reflect anywhere, but we're going to stay simple. And we're going to remember that a reflection is a mirror image of the original figure. Now the figure is going to keep its same size and its same shape. So the pre-image and the image will be the same shape, just reflected. They will be congruent, and congruent means to keep the same shape and the same size. So when we look at this triangle, this blue one becoming the green one in either one of these pictures, it's the same triangle. It didn't change length of side or anything like that, and that's what it means to be congruent. There are three what are called rigid transformations. Translation was the first, reflection is the second, and we will do a new one after we finish reflections. What it means by being rigid is that whatever shape you started with, it is congruent. It stays the same shape and the same size. It doesn't change. So that's what rigid means. So the line of reflection that you'll see kind of highlighted down here, like I said, we're going to use the x-axis as a line of reflection. We're going to flip a shape over the x-axis, and the y-axis will be our line of reflection. We're going to go left to right or right to left across that y-axis. So if we look up here, let's just talk about the general thing of what's happening. We're going to start with a pre-image of this blue triangle, and the coordinates are here. So -2, which would be 2 to the left, +1, which would be 1 up. That's the coordinates for this vertex corner point right here. -4, 4 to the left, and 4 up would be the coordinates for this vertex, and -4, 4 to the left, and up 1, that would be the coordinates for this point. When we reflect over the x-axis, notice that this corner point, this vertex that I'm moving the cursor on, -4, 1, it's 1 up from the x-axis, which is the line of reflection. So the new shape, the image, is going to be 1 below. And this point, -2, 1, is 1 above the line of reflection, so it's going to go 1 below. And this point up here, the uppermost vertex, was 4 above, so now it will be 4 below. So that's how you can tell on the graph paper, the reflection, the points move in the opposite direction over the line of reflection the same amount. Over here, we're going over the y-axis, so you'll notice, see this point right here, -2, 1, is 2 to the left. So the new triangle would be 2 to the right, and so forth. Now, let's just talk about the coordinates, though. You don't actually need to do this on graph paper. So if you kind of look at the blue and the green triangle in the left example here, which is reflecting over the x-axis, notice that the x-coordinates stay the same, but the y-coordinate changes sign. And that's true of every point. So look at this uppermost point, -4, 4. The x-coordinate in the image is -4, -4. So the x-coordinate stays the same, but the y-coordinate changes sign. And that's true of all 3 points. So when you reflect over the x-axis, the x stays the same, the y changes sign. When you go over the y-axis, the opposite is true. So if you look here, look at this point right here, -2, 1. We're going over the y. Now the y stays the same and the x changes sign. So it didn't move up or down, it just moved left or right, and that's why the x is changing sign. So if we go up to one more point, and again, we're going around the y-axis. So notice that the y-coordinate stayed the same, but the x changed. So -4 became 4, but the y stayed at a 4. And that's how you can move it without even looking at graph paper, and that's what happens in a computer program. So here's an example. We're going to start with a triangle that has the 3 vertices right here, and I plot them down here. So remember, your coordinates, kind of like playing that battleship game. You're going to go 5 to the right and 2 up, and that would be A. You're going to go 1 to the right and 3 up, that would be B. You're going to go 1 to the left and up 1, and that would be C. Now, if we're looking at it on the graph paper to reflect, notice I put that reading strategy of circling the x-axis. So I know I'm going over the x. So the C was 1 above, so C prime will be 1 below. The B is 3 above, so B prime will be 3 below. The A is 2 up, so A prime will be 2 below. And that's how you can see it on the graph paper. But like a computer, we need to have an instruction, a line of code. And here we're going to talk more about just looking at the coordinates. So if we're going over the x coordinate will stay the same and the y will change sign. So 5, 2 becomes 5, -2. The B, the x coordinate will stay the same and the y will change sign, so it'll become 1, -3. And same on C, the x will stay the same since that's the axis of reflection, the line of reflection. So the x coordinate stays the same and the y changes the sign. So when you reflect across the x coordinates stay the same and the y coordinates change sign. And in shorthand, kind of like that translation notation, well, the reflection notation, we can see that the x coordinate stays the same and the y changes sign. So in example 2, if we had our book, it would be on page 463. Notice this time we have 4 corner points, 4 vertices. It's a quadrilateral, so it's a 4-sided figure. It doesn't mean it's a square. It doesn't mean it's a rectangle. And as you see in the picture, it's not. It's just 4-sided figure. And here are the vertices. And we're going over the y-axis. So it's really simple to get the new coordinates right now without even looking at the graph paper, because this time, since we're going over the y will stay the same and the x will change sign. And that's kind of the little cheat I've got down here. So this wouldn't be 2, 3 when we've reflected over the y. It'll be -2, 3. And you can kind of see the points right here. So we are going to keep the y the same and change the x, so -5, 1. We're going to keep the y the same and change the x, so -4, -2. We're going to keep the y the same and change the x. And if you plotted these 4 points, you would see the k prime, l prime, m prime, n prime would have reflected across the y. So, just notice we started with the blue one here. Here's the 4 points that they listed. And then we're reflecting over the y, so the k was 2 to the right, the new k will be 2 to the left. And just look at that k prime, its coordinates would be -2, up 1, 2, 3, 4, up 3. I couldn't see where that was. So it's actually up 3 because the axis is right here. I had the origin at the wrong spot. So 2 to the left and up 3 instead of being 2 to the right and up 3. So when you reflect across the y-axis, this time the y will stay the same, but the x will change sign. So what I'm going to ask you right now is to pause the video and try to do this one yourself. Now, graph paper, coordinate graph paper, whatever, works for you to try this. But you can also just use the coordinates and be able to kind of plot it back. So right now we want to know, what will the new coordinates be if triangle PQR having those vertices is reflected, and notice what I'm doing for reading strategies, y-axis. Write your new coordinates, and if you have the ability to the graph paper, go ahead and draw the original, and which would be the pre-image and the image after you reflect it. Once you are set, unpause the video and let's see how you did. Okay, so we're going to remember that when we reflect over the y coordinates will all stay the same and the x's will change signs. Let's come on over here and see I plotted the original. That is the pre-image in green. And now I'm going to change. So notice the y coordinate stayed the same and the x changed sign. So this is going to be the new coordinates, and I could come over here and plot them. So there are two ways to kind of graph this reflection. You can graph the original and just count if q is 3 to the right, q prime will be 3 to the left. You can do it that way. Or you can change the coordinates and then come over here and plot, that q will be -3, 7, q prime. So again, remember, since we're going over the y-axis, the y stayed the same and the x's changed sign. And if we plot that image, it will look like this. Okay, let's move on. Where does this stuff get used? Because, those video games, we're beyond Pong, and we're not just talking about, rectangles moving around or something like that, much more elaborate. So here you can just kind of see a picture. If they wanted to make something symmetric, that's kind of what they're doing in this picture with half of a frog, go figure. But anyway, if you look at point A, and we find the origin right here, notice point A is 1 to the right and up 4, so that's where you're seeing the coordinates 1, 4. And what they're saying is they want to get the other half of the frog, so they're going to be reflecting that over the y-axis. So if you're going over the y, notice the y stayed the same and the x changed sign. So if you were to come over here and plot -1, 4, you would kind of get the other hand, where that hand ends on the frog. And then if you look at B, B is 2, 1. And if we change the x and keep the y, then the b would be at -2, 1. So you can kind of get a feeling as to where those points would have to be. And you can actually draw the frog in kind of more easily, having those points to make it perfectly symmetrical. Let's move on to take a look. So here's one where you've got half of the sun and you've got to somehow draw the other half. So it's nice to have what I call reference points, like we did on the frog. This time we're going to go over the x-axis. So if you kind of start with these original 2 points, get their coordinates, and reflect them to be on the other side, you can put those reference points in and kind of know how to draw that sun in. So if you want to give it a go, if you've got some graph paper, or you could just right now, with the original coordinates, write those down and just try to reflect them to get those reference points. If you have graph paper and actually want to draw it, feel free to do that, but you want to pause the video because we're going to move on from here. When you're all set, unpause the video and we will move on. Okay, so if you looked at the point A and B, these are the original coordinates. So A would be 2 to the left, -2, and up 2, which would be -2, 2, and B would be +2, 2. Now, if we're reflecting over the x, the x's are going to stay the same and the y's are going to change sign. So if we look at -2, 2, right here is going to be the reference point A prime. I'm kind of circling it. And B would be at 2, -2. And you could put those points and then it would make it easier to try to draw the sun. I mean, I'm going to cheat. Shh, don't tell anybody. But you see that reference point right here would have been the end of that middle triangle. And you could kind of back in and draw around it. Same thing over here. The -2, -2 would have been this one, which is the middle triangle. And then you could kind of draw the other two around it. Okay, so just to finish today, the left-hand one is probably the better one, not having the book, but you are welcome to try both to find over here. It's the 2 reference points, And over here, you're going to take a triangle and reflect it over the X. This one, of course, is reflecting over the Y. So pause the video and see how you do. And you come back, we'll check your reflections. Okay, everybody, let's see how we did. So I'm going to draw the picture for you over here. So A would be 5, 1, B would be 1, 2, and C would be 6 to the right and up 2. That's the original triangle, and we're going to reflect it over the x-axis, which means that the x coordinates are going to stay the same, but the y coordinates are going to change sign, and you can see me doing that right here. So if I was to plot 5, -1, that's A prime, 1, -2 is B prime, and 6, -2 would be C prime. That's one way to do it. The other way is to realize that the A was 1 above, so A prime is 1 below the line of symmetry, or the line of reflection. And the C is 2 up, so C prime would be 2 below. The B is 2 up, so the B prime would be 2 below. So there's kind of two ways to do it. You can draw it off the picture, or you can just use the coordinates. Now, if we were trying to kind of make this flower perfectly symmetric, it would be helpful to have reference points, although they only kind of gave them to you on the top. Now, notice that A is on the line of reflection. So it's on the line of reflection. So again, the y's, would stay the same and the x's would change sign, but because it's on the line of reflection, it's 0, and 0 isn't positive or negative. So it's not moving anywhere. It's going to stay there. The B, however, the 2 is going to become a -2, and the 4 will stay the same. The y coordinate stays the same, and the x changes, and you kind of get that reference point. And it kind of helps you there. They really should have created one, somewhere else to kind of help you. But, that's how you can create something to be perfectly symmetric, is to draw half of it and reflect it over a line of reflection, and you'll get a perfect symmetric picture. It's been studied that we as humans love things that are symmetric. We are drawn to things that are symmetric as being beautiful. So a lot of people, when creating logos for products or different characters or things like that, they will try to make them be symmetric, perfectly symmetric, and they are more appealing to us, which I find kind of interesting. So today, everything was about reflecting. If you go to look in the mirror, you'll get a better feeling for that. But today, again, reflections. Tomorrow, we're going to give it some practice. And the thing to remember is, when reflecting, the axis will determine which point stays the same. So if you're reflecting over the y coordinate stays the same, and the x changes sign. Guys, I hope you have a great day.